The part 4 of the video how to do experiments with analog electronics. It's all quite sloppy, sorry for that. I only want to give a kind of talk, more or less for beginners, but on the other hand it shows my experience during the 40 years or more, 50 years of electronic experiments, and perhaps it can help for everyone liking to do analog electronic experiments. In the earlier video we talked about this. I hadn't talked about the second breakdown effect that only, as far as I know, I have to say that, works with bipolar transistors. So we have here a bipolar power transistor. It has a load in its collector lead. Could be everything: power, resistive, capacitive, inductive, and of course there's much to tell about the problems when a bipolar transistor or whatever transistor has an inductive load between the collector and the power supply. Could also be reversed in case of an NPN transistor, PNP transistor, but anyway, when this is, for instance, not a resistive load but an inductive load, and everyone knows that, and I've had many comments about my circuits in the past when I did not mount here a diode. Anyway, an inductive load, not always, but it could be that when it's activated by the transistor, say we send in here via capacitor a certain frequency, let's say 18 kC, and that coil is also tuned to that frequency or not tuned to that frequency. When it is tuned to that frequency, it will give out its best maximum oscillation anyway. But when the magnetic field inside of that core, say it's ferrite, often ferrite, collapses, there is a voltage pulse sent back to the transistor circuit, and that could be so high that the transistor is damaged. That's the reason why often you see here a protective diode, and when you study MOSFETs you can see MOSFETs that such a protective diode is mounted between the source and the drain. I draw it now in this way, but of course that depends on the type of semiconductor, N MOSFET or P MOSFET, and of course on the World Wide Web and in data sheets you can find everything about that. Both the protective effect of such a diode, etc., etc. Another way to protect, in this case the transistor, is positive here, negative here, here that coil. There are a few ways to do that. At first, damping with the help of a resistor. Such a resistor, often in the high ohms range, say 100,000 ohms, could be 47 kilo ohms, makes that that backfire signal, that backfire voltage when the magnetic field collapses, is damped. So this acts as a damping resistor. that's also a good idea to get that problem solved. Another idea is, that will not always work of course, but anyway, to mount here a capacitor. Of course, that capacitor must not be too low, but it will change the frequency where the whole circuit oscillates. That means, because this is in fact a tank circuit, so an LC circuit with time dependency. That means that when you send in 18 kC, could be that this coil does not get to its proper resonance. Anyway, standard classic solution is that protective diode. So this is the classic solution with a relay, for instance, and you always see this here, such a diode. I often use a 1000 volt type diode. 1000 volt, very cheap, from the 1N XXX family. Here I have my medium power diodes. Many of them can handle 1000 volts, and here power diodes. So that's a quite good solution, but in many cases you can use that resistor instead of the diode. And the good thing of a resistor is that it is not frequency dependent. So could help. So you can get that coil into oscillation, preventing it to damage the transistor, etc., etc. And of course, when you go to real high voltages, you use a typical high voltage transistor. And the problem with high voltage transistors is that their amplification factor, and here you see quite a few of them, high voltage transistors, their amplification factor is in many cases not very high. Better to say it's extremely low, 5 times or otherwise. And I have to say that I only tested these high voltage transistors not in a real high voltage circuit for where they were made for, but with a normal transistor tester like this.